Hello, linear momentum. If you have not seen this before or you are studying physics, you find it difficult to understand. So this lecture will assist you. I'm going to break everything down. So don't run away. So we are going to firstly we are going to define Newton's laws of motions. Then we look at force, impulse, and momentum itself. Then we look at formulas. Then we look at calculations. So Newton says that for instance, this is a table. This is a table. For instance, this is a table. I believe you are seeing this is a table, and under this table there is an object. So in physics we call object a body. This marker is a body. This board is a body. I'm a body. You are a body. The earth is a body. So let's progress. So let's say this is a body. So this body that is on top on this table, it will remain at this position. It will remain here forever until you apply force on it. But it will remain here forever. Are you getting me now? It will remain here forever until something apply force on it. For instance, this is a ball, and this ball have mass. So this ball, if this ball is flying in a uniform velocity, are you getting me? If this ball is flying in a uniform velocity, so this ball will continue to move forever. This ball will continue to move forever until external force apply force on it to stop it, or another player stop it with his leg or with his chest or with his head. But this ball will continue to move forever. But the point is that why is it that if you shoot a ball without anybody stopping it, it will come down? Why? Because there is a gravitational force. If that gravitational force is not there, all those astronauts that are going outer this space, in the outer this space, there is no gravitational force. If they are flying, they can fly without gravitational force pulling them down. Why? Because there is not gravitational force in the outer the space. Are you getting me? There is not gravitational force, or they can stay at one position without gravitational force pulling them down. Are you getting me? So we are going to start with the definition. So this is the Newton's first law of motion. So this is the first definition of Newton's first law of motion. So the definition says Newton's first law of motion states that every body continue its state of rest. Are you getting me? Or uniform motion in a straight line unless compelled by some external force to act otherwise. This is a very simple. That example that I give you, the same example that I give you. For instance, this is a ball. So if this ball is flying in a uniform velocity, in a uniform motion, and this ball have mass, so if this ball have mass, so if this ball is flying in a uniform velocity, this ball will continue to fly unless external force apply on it, but this ball will continue to move forever. This ball will continue to move forever. For instance, the same example that I give you, for instance, this is a table. This is a table. For instance, this is a table. I believe you are seeing. For instance, this is a table, and on the top of this table there is an object, there is a body on top of this object. So this body will continue at this position forever unless some external force apply. If you didn't apply force on it, it will not move. It will continue at this position forever. Are you getting me? It will continue at this position forever. So that is what Newton's first law of motion is talking about. Are you getting me? So for the second law, the second law says the Newton's second law of motion state that the rate of change, are you getting me? The rate of change of momentum, the rate of change of momentum of a body is proportional to the applied force and take place in the direction in which the force acts. It's a normal thing now. So whenever you hear the rate of change, what is momentum? So momentum, what is momentum? What is momentum is m times v. This is momentum. What is the formula to calculate momentum? Mass times velocity. Are you getting me? So the formula to calculate momentum is mass times velocity. For instance, this is a ball, and this ball have mass. So this ball, for this ball to move, you need to apply force. So that move will bring velocity. If you didn't apply force on this ball velocity will not come. Are you getting me? So velocity will not come. So if you want this ball to move, you need to apply force on this ball. So this, after you apply force on it, so that movement will bring velocity. Are you getting me? So the rate of change, whenever you hear the rate, time, the rate means time. So I'm sorry, mv. So this is momentum. Mu minus mv. What is mu? Mu means initial velocity. Are you getting me? Initial velocity. And mv, final velocity. For instance, this is a ball, and this ball is flying, and this ball come here. So this ball is moving, This ball, for instance, let's say this ball have 10 meter per seconds, and this ball from here to here, this ball come here from here to here, and after this ball come here, the velocity of the ball increase to 20 meter per seconds. The rate of change of momentum, so the ball is flying. So this is initial velocity and this is final velocity, because the ball start from at rest. The ball start moving with 10 meter per second to 20 meter per second. This shows that for this ball to increase velocity from 10 meter per second to 20 meter per second, you need to apply force on it. You need to add a force. For example, this ball come here and this ball, you apply a force on it. So that force that you apply, let's say the force that you apply is turned in. Let's say you apply a force and the velocity of the ball increase from 10 meter per second to 20 meter per second. So this is the final velocity, because the ball increase the increase of the speed of the velocity of the ball increase from 10 meter per second to 20 meter per second. So this is momentum, and this the rate. Whenever you hear the rate means time. So this is the rate of the rate. This is momentum, and this is the rate of change on momentum, where it is before minus where it is now. The rate of change over time, the rate of change of momentum. So that is the second Newton's law of motion is explaining. So the third law, which is very common. So Newton's third law of motion states that whenever a force add on one body, for instance, this is a man, and this is a man. So this man give this man a dirty slap, pop. So this man that slap this man, for him to slap him, he need to apply force. So this man give him the same force that he give him. He give him force, and he give him the face. The face give him the same force that he applied to slap him. Are you getting me now? So for instance, let me give you another example. For instance, I have a gun. So if I have a gun, I shoot a straight, for instance, I shoot a thick vertical wall. So my bullet to penetrate that wall, he need to apply force on that wall. So my bullet, for instance, this is my bullet. For instance, this is my bullet. So this is the thick wall. So my bullet come for my bullet to penetrate the wall, he need to apply force. So he penetrate the wall. So and then the wall stopping my bullet. So for the wall to stop my bullet, he need to apply the same force that my bullet apply force on him. Are you getting me? He need to apply the same force that my bullet apply to penetrate it. He need to apply the same force that my bullet apply to penetrate in the wall. So you wall, you need to apply the same